thing I'm going to do here is put some measurements on the diagram. We're told that the base is a square, and also all of those lengths around the bottom are 20, and the height of the pyramid is 15. Okay, so first of all, for the length of the diagonal AC, well, we can see that AC, or the ABCD on the bottom, is a square. I'm looking for this length here, knowing that that's 20 and that's 20. So AC squared is just going to be 20 squared plus 20 squared, which is 400 plus 400, which is 800. So AC is the square root of 800. Now I'm going to write that. I've realised I can rationalise it by making it into 400 times 2, and then split that into the square root of 400 times the square root of 2, which is actually just going to be 20 root 2. Okay, in part 2, I'm now asked to find the length AV, so that's the distance from here to here. And the easiest way to do that is to use the triangle which goes from V down to O, where the height is 15, and then from O to A, because I've just worked out the distance from A to C, which is 20 root 2, which means that the distance from A to O must be half of that, so it must be 10 root 2. Okay, now to show that the length of AV is root 425, I'm going to use Pythagoras again. So AV squared is going to be 15 squared plus 10 root 2 squared, or you could also have that as half the square root of 800. This is the simplest way of doing it, though. I think the neatest way of doing it. So that's 225. If you square 10 root 2, you have to square the 10, which gives you 10 squared is 100. You square the square root of 2, and that just comes out as 2. So what you're doing is 225 plus 200, and 225 plus 200 is 425, which means that AV is equal to the square root of 425. That's probably the neatest way. Now, part 3 says the angle that AV, so here's AV, the angle that it makes with the base, well, that's just going to be this angle here. Now, to find that, I can just write that tan theta is the opposite, which is 15, divided by the adjacent, which is 10 root 2. And if I work that out and do shift tan, it comes out as 46.686. So that's 46.7 degrees. Next part of the question says calculate the length of Vn. Now we know that Vn is from the top here down to the center. I'll draw it over here. So we are trying to find, there's n. We know that from A to N is going to be 10 units because it's halfway from A to B, because this is the line of symmetry of this isosceles triangle, and we are trying to find this length here. This will be a right angle, and we've just worked out that AV is the square root of 425. So if we want to now work out Vn, well, Vn squared is going to be VA squared minus AN squared. Now, if I square VA, I'm just basically squaring the square root of 425, which is just going to be 425. If I take away AN squared, well, that's taking away 10 squared, which is 100. That comes out then as 325. So Vn is the square root of 325. The question now goes on to here and says calculate the area of triangle VAB. Well, we've just worked out, sorry, that's not very straight, that the distance from V to N is the square root of 325. And the reason that's useful is because I can work out the area of a triangle using half the base times the height. Now, to work out the area of the triangle, then I'm going to use AB as the base. Well, AB I know to be 20. And the height, which must be perpendicular to the base, is going to be the square root of 325, and I'm going to multiply that by a half. So I get 10 times the square root of 325, and that is the area of this whole triangle. It then says calculate the distance AM. Now I can see that AM is perpendicular to this side, so I can also work out the area of the triangle by doing half base times height, using that as the base and that as the height. So I know that half times the base, well, I'm going to use VB as the base, well, that's 425, times the height, well, that's AM that I'm trying to find, That is going to equal what I've just found to be the area of the triangle, which is 10 root 325. If I double both sides, then I've got the square root of 425 multiplied by AM, doubling both sides, that's going to equal 20 root 325, which basically means I then have to work out the area of the triangle. AM then, so to find AM, A is going to be 20 root 325 divided by the root 425, and that comes out as 17.489, which is 17.5 centimeters to 3 significant figures.